The joining table serves as a means of production to assemble various spirals into a sieve. Can wagon, used for storage and supply of spirals at the joining table, and is equipped with a deflection frame which can be fit onto the can wagon to deflect the spirals out of the cans in the right direction. The guide rakes transport the individual spirals to a profiled joining roller pair, which connects the individual spirals. A subsequent rubber roller pair ensures a constant feed from the spiral belt. The cutting unit then draws in the spirals and cuts them to the programmed length. The spiral belt moves from the joining unit to the conveyor belt, whose speed is synchronized with the rubber roller feed. The conveyor belt is made out of plastic-coated tissue. It is driven by a frequency-controlled three-phase motor. The conveyor speed is set via the machine controls or using the target value potentiometer. Up to 72 coils of type K250 can be stacked on the creel. A pull-off roller is mounted in front of the fixing box to facilitate pulling off the Pintle wires from the creel. The Pintle wire is wrapped once around the pull-off roller. In order to ensure smooth insertion of the Pintle wires, the wires pass through a Pintle wire fixing box in which the Pintle wires are heated and straightened. The drive unit for the Pintle wire is primarily composed of a transport roller pair, a cutter, and a template that distributes the wires to the exact pitch of the spirals. The transport roller pair consists of one rubber roller and one hard roller which are pressed against one another. This ensures that the wire feed is carried out with very little slippage. As soon as the Pintle wires have been completely pushed through the sieve, they are cut off by the cutter. The winding unit is used for rolling and stretching the pieces which have been joined together. With a winding motion under tensile stress, the spirals are pulled apart from one another, so the Pintle wires can no longer be inadvertently pulled out of the sieve, and to optimally prepare for the subsequent process steps. If needed, short and long winding tubes and tubes with various diameters can be clamped. Both chuck jaws are adjusted with the respective square keys, such that the diameter of the winding tube fits the smaller tube diameters in, the larger over the clamping jaws. The movable console of the winding unit is pushed far enough to the left that the winding tube can be stuck onto the chuck jaws on the drive unit using a crane. After horizontally aligning and lightly applying the clamping jaws, the console can be pushed to the winding tube until the clamping jaws grip into the tube. By means of the mechanical height adjustment of the console, the tube is now aligned exactly horizontally on the rollers. The larger the distance between the clamping jaws and the sliding console, the larger the diameter of the winding tube must be. Now the console clamping jaws are also lightly applied. The chuck jaw keys are then inserted into their holders. If the keys remain inserted, it can lead to equipment damage during winding. The wire coils are placed onto the creel intakes such that the driver pins catch between the coil ridges after overcoming the resistance of the cage springs. The wires are now fed through the deflection roller on the brake lever and onto the guide loops. The wire from the rearmost coil is guided through the first loop from the inside. That is, the wires are fed from the back, inside, to the front, outside. Tie the wires of the same level together until they enter the machine, so they cannot fall out of the guides. When feeding in the Pintle wires, the drive roller is first moved upwards in the drive unit, button, lift roller. The Pintle wires can now be fed from the creel into the drive unit. Beginning above on the operator side, the Pintle wires are fed from the outside to the inside by the guide loops, and guided through the separating rake with a clinch to the takeoff roller. Then the wires are guided in the same order through the fixing box, heater, the drive unit and the template. To guide the wire easier through the drive unit, you can remove the acrylic glass. Then guide the Pintle easily from the back, through the middle, to the front template. Once this is done, put the acrylic glass back into its holder. After that, the drive roller is lowered back down, button Lower Roller in Setup menu. The Pintle wires can now be moved out of the template with the target value potentiometer. By pressing the cutter button, the Pintle wires are cut into unified length. The height of the conveyor belt is then adjusted as described in section 2.4 in order to optimize the intake of the Pintle wire into the spiral joining. The wire feeding unit is designed as an exchange unit and can be replaced if necessary. Replacement of the matrix set is required when converting the system to a different spiral size. By using different spiral sizes, the spiral wire drive unit must be rebuilt with the appropriate components for the Pintle wire guides. To do this, lift the drive roller first using the Lift Roller button. Then remove the two acrylic covers. Then tilt down the 4 tension levers and carefully pull out the matrices. Now loosen the dividing plate with a small Allen key, and then remove it as well. Now you can put the new matrix set in the reverse order into the drive unit. Finally, tighten the screws firmly again, tilt the clamping levers back up, and put the acrylic covers back into their holders. Also lower the drive roller again with the Lower Roller button. Once this is done, the replacement of the matrix set has been successfully completed. A height adjustment is only required when setting the machine to another spiral or sieve type. The conveyor belt is synchronously adjusted manually using lifting elements that are mechanically connected with one another. A reversible ratchet is mounted onto the shaft journal of the first lifting element, and belt height is adjusted by turning in the corresponding direction. The current value is displayed in the controls on the belt height field. The height to be set corresponds with the height dimension of the spiral size used, plus 0.5 to 0.6 millimeters. The guide rails of the joining channel need only be replaced if the new sieve geometry requires a different width of the sieve segments. The replacement takes place by loosening the screw connections on the top of the strips. When loading the spiral cans, always alternately place cans with right-wound and left-wound spirals. The cans are marked with colored tape to distinguish between spirals rising to the right and to the left. The cans marked with tape contain spirals rising to the right. The spirals placed in the can wagon are guided through the separating rakes one after another, as shown in the graphic. In order to enable the joining of the spirals, left and right spirals must be alternately placed next to one another in the joining unit. When feeding the spirals, always start with the first spiral on the front side of the can wagon. This is fed into a borehole in the outermost button row of the separating rake. The next spiral is then taken by the can behind it and guided into the borehole above it in the separating rake. There should be no overlapping of the spirals, as they can hook together. In order to hold onto an initial piece for joining, press the two spirals into each other, so that a small channel is created. Insert a 200 mm long piece of Pintle wire into this channel to connect the two spirals. Spirals are attached to spirals from bottom to top, or rather from front to back. All of the settings and machine commands necessary for setting up and operating the joining unit can be made from the control panel on the joining side of the machine. The prepared initial piece is then inserted into the joining unit after lifting both rollers in the feeding direction. Before that, the left acrylic cover must be removed and replaced after retracting the initial piece. Now the roller can be lowered again with the button Lower Roller. Push the initial piece through the feed roller by hand until it is under the second acrylic cover. Then, after lowering the rollers in manual mode, the spirals are pulled into the joining unit with the feed roller with feed regulator until the joining section sticks out above the cutter into the joining channel. The cutter can then be used to remove the excess. When cutting, the length measurement of the spirals is automatically set to 0. Once the joining section has been cut and removed, the joining channel covers can be closed. The joining unit is now ready for use, and after checking and adjusting the necessary production parameters, Sieve production can begin. The forked photoelectric sensor built into the joining unit measures the spiral lengths pulled in by counting the spiral coils and calculating in millimeters via a factor stored in the controls. This factor can be adapted in the Parameters menu if needed, or a referencing can be made. The joining unit is designed as an exchange unit. The replacement of the joining unit is required when converting the system to a different spiral size. When using a different spiral size, an exchange unit with the appropriate profile roller and the corresponding joining channel width has to be used. The exchange is done in a few steps. Loosen the 6 mounting screws on the spiral inlet side. Now disconnect the hearting connector of the unit and disengage the drive motor by pushing back the coupling ring. Now the complete unit towards the operator can be removed from the base plate. The installation of the exchange unit is done in reverse order. Make sure that the unit is pushed in until it stops. The leading edge of the exchange unit must align with the leading edge of the guide plate after the cutting blade. A steel ruler should be used for that purpose. Also, the guide plate must be replaced after the cutting unit. This is done by loosening the 2 screws by means of an Allen key. Then tighten the 6 fixing screws again. Connect the hearting connector with the unit and connect the drive motor by means of the coupling ring also with the unit. All important machine functions can be centrally controlled from the main control panel. Start screen for controls after switching the key switch to position on with display of current operating data and buttons for choosing between various operating modes and functions. General error messages are highlighted in red, quit error messages and faults with this button. Stop the joining process with the stop button. In the operating modes semi-automatic and automatic, go back to the corresponding step with this button. This message indicates that the plug-in connection to the removable module requires verification. Yellow highlighted error messages show status deviations from the process specifications. This button indicates that the roller is not yet in process position. Here you can see that the conveyor belt is occupied. Only after removal of the still existing sieve section, the joining process can be continued. The heating was not switched on, or is not in process temperature. With these buttons you can set the counter reading as well as the set point potentiometer to 0. After switching on the Pintle wire side main control with the key switch, the control of the joining side also moves up. Both displays show the start picture of the control with the current operating data and buttons to select the different operating modes and functions. In addition, there is a control panel on the joining side with a feed potentiometer to feed in the spirals and a button to cut off the spirals. On the metal covers of the conveyor belt, distributed over the entire length, there are several pressure keys with which you can individually open and close the covers of the conveyor belt. All adjustments are carried out in the manual operating mode and in the setup menu. The menu for setup mode is called up with the setting button on the basic display in the main controls. All machine functions required during adjustment, such as lifting and lowering of feeding rollers, only possible with closed safety covers, hold-down clamps and separation panels in the Pintle wire drive unit, as well as processes for the whole unit, can be individually controlled. The brake unit functions, such as lifting and lowering of the deflection roller and the closing and releasing of the brake, are also controlled with the buttons in this menu window. The functions of the joining unit can be controlled directly on the small control panel on the joining side. At the joining unit, no adjustments are required because it is designed as an exchange unit and designed for the respective sieve size. First, remove the hold-down clamp. Loosen both of the star grip screws and remove the hold-down clamp. Now cut the Pintle wire to the same length. Now move the drive unit forward by pressing the Unit Forward button in the setup menu of the main controls. The Pintle wires can now be moved a few millimeters out of the matrix via the set point potentiometer. By means of a feeler gauge, the wire feed unit is now adjusted in height so that the Pintle wire can pierce the spiral structure in the center. The height adjustment is carried out by using a hand wheel on the control element on the inlet side of the drive unit. After installation of the hold-down clamp, the Pintle drive unit is ready for use. The heating of the Pintle wire fixing box must be switched on well in advance before the beginning of the sieve production, so that the required process temperature is reached at the start of the joining process. The process temperature is controlled by using the touchscreen in the Parameters menu. Not all of the joining table's functions can be individually and independently controlled in this operating mode, as they can in setup mode. The operating mode is selected with the manual button on the touchscreen of the controls. The covers in the joining channel are closed with the central close button. By turning the feeding regulator to the right from 0 position, the input and joining of the spirals begins on the joining side. After the set value spiral feeding has been reached, the conveyor belt and the joining roller stop. The feed and belt speed is regulated via the parameters in this operating mode. The joined sieve can now be cut with the cutter by pressing the button under the feed potentiometer. By pressing the button Belt forwards, the sieve section is conveyed to the Pintle wire unit. As soon as the sieve section reaches the first sensor in the Pintle wire unit, the belt speed is automatically reduced. Upon reaching the second sensor, the belt stops with a delay, in the final position required for inserting the Pintle wire. The adjustment of the sensors is done by password-protected parameter area. Using the Function Fit Spirals button, the hold-down clamp is lowered to fix the end of the sieve section. By turning the feed control unit to the left, the separating panel is lowered in front of the cutter. The Pintle wires are then moved a few millimeters out of the template and the feeding stops automatically. After pressing the button Insert Pintle Wire Position, the Pintle wire unit moves forward and inserts into the sieve section with the Pintle wires that have been drawn out. By once again turning, left from the 0 position, the target value potentiometer or feed control unit on the Pintle wire side, the Pintle wire is inserted into the sieve section. After the preset length has been reached, the feed automatically switches off. The Pintle wire is now cut by pressing the cutter button. The belt is then moved out a small length from the feed unit with the button Belt Reverse. After opening the joining channel panes, button Central Open, the finished sieve section can be removed from the joining channel and placed back onto the table. In automatic mode, you can select again between semi-automatic sequencer and fully automatic one joining process. Before starting the joining process, all feed potentiometers must be set to 0. All basic conditions must be met, meaning that no buttons can be yellow. The feed speeds are automatically regulated according to the preset values. Please note, when pressing the stop button or turning off the machine with a safety device while the automatic cycle is running, the controls shut off automatically, and the interrupted joining process must be completed in manual mode. The next joining process can then be run again in semi-automatic or automatic mode after the problem has been corrected. In this setting, the individual production steps are displayed on the control screen and enabled individually by the operator by pressing the touch screen. When you press the button Call Spirals Extend Pintle Wire from Matrix, The drives of the joining unit and the conveyor belt start. The spirals are fed in until the preset length is reached, and the joining unit cutter cuts the corresponding lengths. The joined spiral section is now conveyed to the hold-down clamp of the Pintle wire unit via the conveyor belts. When you press the button Fit in Spirals, the joined spiral section is jiggled down with short impulses by the hold-down clamp on the Pintle wire side, and then held. At the same time, the drive unit moves the Pintle wire from the template until it enters the spiral joining by a few millimeters. The third step, plunge Pintle wire, by moving the short stroke cylinder, the template is moved forward until the Pintle wire is a few millimeters into the spiral joining. If the individual wire misses the intended channel and runs into a spiral, the feed automatically shuts off, and the fault indicator flashes. The production step must be manually completed by fixing the fault and accepting the fault message. When you press the button Measure Length of Pintle Wire, the feed pushes the Pintle wire into the spiral joining and automatically stops when the preset Pintle wire length is reached. Before the final length of the Pintle wire is reached, the Pintle wire feed switches to a slower speed to ensure that the Pintle wires are sufficiently fixed. This parameter can be changed in the password-protected area. The hold-down clamp is lifted. When there is set excess of the Pintle wire, the conveyor belt moves backwards synchronously with the feed. In the last step, press the button called Cut Pintle Wire Open Jointing Channels. The Pintle wire is cut to the intended length. The belt then moves backwards a short distance so that the Pintle wire that has been cut to length is pulled out of the template. The joining channel panes then open. The production cycle is complete, and the finished sieve parts can be removed from the joining channel. In this setting, the individual process steps, as described in semi-automatic sequencer, are automatically processed in sequence by the controls. The individual sieve sections are joined by manually inserting a Pintle wire that has been cut to length. First, the sieve section that has just been produced is placed next to the end of the finished sieve so that it slightly overlaps, and then joined with a plastic roller. After an initial section is joined, the Pintle wire is inserted into the channel that has now formed, and pushed in a few centimeters. The sieve section is now joined across the entire length as described. Finally, the Pintle wire is inserted up to the intended length. The length is then identical with the length value set for the Pintle wire drive unit. After a few pieces have been joined together, the sieve piece is pulled through the rollers of the braking device. The deflector roller is therefore pneumatically lifted by pressing the Lift Deflector roller button. Then the sieve is placed over the winding tube. Now the screen is repeatedly fixed to the pipe with adhesive tape. After that, the guide roller is lowered again. To wind the finished sieve, the wind button is pressed on the control touchscreen. The winding roller is then wound under tension by a geared motor and the 3 rollers of the braking device. The stretching firmly fixes the Pintle wires into their channels. Press the corresponding display field to program or change parameter values. A window appears with a number pad for entering the desired values. The entry is subsequently confirmed with the Enter button and transferred to the controls. The new value is now in the number field of the parameter display. Press the corresponding display field to program or change parameter values. A window appears with a number pad for entering the desired values. The entry is subsequently confirmed with the Enter button and transferred to the controls. The new value is now in the number field of the parameter display. After each change of spiral size, the length factor has to be reset. The length factor has to be set on the joining side controls. By pressing the parameter button on the basic display, the parameter overview is called up. Next to the display of the current values, use the Search for Reference Measurement button to access the corresponding window. The length factor can be determined there by following the 5 steps. Cut spirals. Press the Cutter button on the potentiometer housing. Remove cut spirals. By cutting, the controls set the length measurement to 0 and reverse by 2 to 3 turns. The actual value display is negative, -1 to approximately -4 mm. Close Joining Channel 1 cover. Extend spirals just up to the reference point mark. The right edge of the cover 1 serves as a reference point. Press Accept Value button. The controls now relate the counted increments to the length advanced. If needed, this value can be changed in the parameter menu of the joining side. This can be necessary if measurement deviations result from high feeding speeds which can slightly stretch the spirals and possibly distort the measurement. The length measurement can be influenced here by slightly changing the length factor. By pressing the Parameters button on the basic display, the menu for variation of production parameters is called up. By entering screen length, the length of the joined parts is set. By entering the Pintle length, the value Pintle length feed can be adjusted accordingly. Please note that the difference in length between the screen length and the Pintle wire length protrude by half on both sides of the sieve. The feed speeds for spiral intake, Pintle wire feed, and rapid feed of the conveyor belt can be changed here. The feed speed for the spirals should be set so that the joining process lasts as long as the time the operator needs for attaching the previously joined spiral section. The belt feed V2, fast, does not need to be adjusted. By entering the heater target temperature, the process temperature in the Pintle wire fixing box can be changed here. Also, the heating can be switched on and off here. By pressing the Service button on the basic display, the menu for selecting the display language is called up. German, English, and Spanish are available. To switch languages, the password must be entered. After selecting a language, a window appears for entering the password. By pressing the button Service Area Parameters, the password-protected area for changing individual machine parameters can be reached. Only qualified personnel from M&A d'Italy GmbH are authorized to access these settings. The same applies to the control of the control display mounted on the joining side. To ensure faultless operation, carry out the following cleaning work at least once a week. Check if the conveyor belt is clean. If necessary, clean it with solvent-free cleaning agent and a soft cloth. The rubber rollers must also be regularly checked for cleanliness. To clean them, also use solvent-free cleaning agent and a soft cloth. Also check the sensors and position switches regularly and replace them if necessary. To ensure fault-free operation and machine safety, regular maintenance work must be carried out. Lubricate the grease fittings of the drive unit with fluid grease. Check the cut-off devices and grind the blades as needed.